Alright, we're back here today. Now I'll get a little figure here. Let's see what we got here. We have a circle and some oddly shaped quadrilateral coming out of it. All they tell us, well, they don't tell us, but I'm going to tell you that C is the center of the circle. The radius of the circle is 1 and A to D is 4. So we'll pop that in there. And it wants to know what the area of this thing is. Looks sort of like a kite. Not really sure if it is. So pause the video, give yourself a shot at it, and we'll come back and we will solve it together. Alright, so let's see what we got here. Looks like a kite. We don't want to really assume that it's a kite. We know the radius is 1, so we know that's 1, we know that's 1. If you knew the formula for area of a kite, I don't know how many people know that. Area of a kite is 1/2 times diagonal 1 times diagonal 2. We don't have that. We don't have that. I don't think that's the best way to proceed. I think anytime, anytime you see a circle with lines tangent, right? Tangent just means touching, connected to the radius. You have to absolutely be on the lookout for the fact that these lines are perpendicular. So those are 90 degrees. Now, rule 2 would be when you see an oddly shaped figure, your best bet is to try to, turn that figure into something more standard, something you're more accustomed to, whether it be a triangle, whether it be a rectangle or a square or something like that, and usually you want to draw a line. And a big mistake kids will make here is they will try to draw a line up here and maybe get this triangle and this triangle. Now the problem is there's 2 problems with that. Number 1, when they give us angles, the one thing we try not to ever do is we don't want to try to split angles that are given. Oops, I can't really spell. We don't want to try to split angles, because if I draw this line, I don't know, I'm not quite sure how it will split. I mean, I would know how it's split if I had this angle, but I don't want to start guessing, oh, it cuts it in half, it's a bisector. I don't like to do that. Typically when they give me a right angle, especially a right angle, I don't want to touch a right angle, because a right angle to me reeks of a right triangle, which reeks of Pythagoras. So we can try to use the Pythagorean theorem. And remember, when we're dealing with circles, a lot of times our lines have to come from the center. In most cases they come from the center because then you can use the radius, you can use the length of the radius. This case, not necessarily, but if we come from the center and maybe we go like this, well, now we're looking at a right triangle, or we're looking at 2 right triangles, right? And so all we really have to do now is just get the area of this triangle and add it to the area of this triangle. Well, here's a right triangle. We have a 1 and a 4. We don't really care what the hypotenuse is. I mean, I'll just put it in there. It's just the square root of 17, right? Which would I would obtain 1 squared plus 4 squared is this side squared. But I know in a triangle, right, area is what? 1/2 the base times the height. In this instance, the base, we'll just call the base 1. So it's 1/2 of 1. And the height is 4. Could do that math pretty easily. That tells us that's 2. And you see these triangles share this hypotenuse, so we weren't sure if this was 4, but now we know it is, because if this is 1 and they share that root 17, then that one must be 4 as well. So if this area is 2, we know that one's 2. 2 plus 2 is 4.